Good afternoon and welcome to our latest MarkLogic webinar, MarkLogic Server 12 Early Access 1. We're going to be talking about how to harness generative AI with the state-of-the-art search found in our MarkLogic server. Joining me today will be James Kerr, software fellow and product manager for the MarkLogic server, whole host of experience using and developing the MarkLogic server. He's going to be giving you a couple of demos, but we'll go through the agenda. So we'll give you a short introduction, framing this latest release. We'll talk to you about the inclusion of BM25 into this early release, along with a couple of demos, including the shortest path and vector operations. What's next? What's coming along in the MarkLogic server product? And then we're going to introduce the customer validation program. This is how you're going to be able to access the MarkLogic early access program.
For the introduction, my name is James Kerr. I'm the software fellow and the product manager for MarkLogic Server. I've been working with MarkLogic Server for quite a while. Started back in 2006 and had a number of different roles throughout the years. But excited to be working as product manager in this new era of search and information retrieval. So as we know, generative AI is really transforming the way people are interacting with their data. AI-powered search is the next generation of search, and our first early access release of MarkLogic 12 is a stepping stone towards allowing our users to be able to maximize the benefits of these capabilities in their enterprise data management systems. Search is in MarkLogic's DNA. The core architecture of MarkLogic Server is a database with the heart of a search engine. Using MarkLogic's powerful indexing and search capabilities, we've been working with customers for decades, solving some of the hardest data management and information retrieval challenges out there. In the era of generative AI, there are new tools and techniques that are pushing the industry forward in how we do search and what we can do with the results from the searches. The upcoming MarkLogic 12 release will continue to build on MarkLogic's history of innovation in search and database management systems by expanding the indexing and querying capabilities to allow you to maximize your benefits from these new technologies. So with that, I'm going to jump in and talk about MarkLogic Server 12 and our first early access release. Quick disclaimer, all the materials here are plans, right? So as this is an early access release, it is a preview of these features. The features can change, plans can change, etc. So what you see in this presentation and in the early access is not a promise of the final deliverables. We'll be making changes as we incorporate feedback from yourselves along the way. So MarkLogic 12 Early Access 1 introduces 3 new features that we have planned for MarkLogic 12. Best match, better known as BM25 relevance ranking, vector similarity operations such as cosine similarity, distance calculation, and a shortest path graph algorithm. And in today's presentation, we're going to go through and talk about each one of these. So leveraging generative AI is really all about being able to find the most relevant data in response to questions. This is nothing new to us. As I mentioned before, the tools and techniques being applied are evolving. They promise significant gains, but also pose new challenges. The new features in preview in MarkLogic 12 EA1 enable you to address some of the key challenges with generative AI. And that challenge is really to find the right data. As we know, there are many approaches to retrieval augmented generation, or RAG, these days, and they're fast evolving. Combining these new features with MarkLogic's already powerful search capabilities allows you to implement the RAG process that you need securely and on your data. Our goal with MarkLogic 12 will be able to build on our already powerful search capabilities to provide you with the most flexible platform to be able to implement the right retrieval augmented generation architecture that you need to meet your business or mission needs. This means we need to be able to find the most relevant data, implement various combinations of indexing, retrieval, and implement different RAG approaches, and do that all in one platform. With that, let's jump in and talk about each of the features. MarkLogic has long had some different relevance ranking capabilities built into our universal index. The primary one that people use is TF-IDF, right? And that's a long standard search algorithm for relevance scoring or relevance ranking. And MarkLogic Server has had a document length normalization features built into it for a long time. But those features are applied at indexing time rather than tunable at query time. BM25 is a industry standard variation on TF-IDF that takes into account the document length more and allows you to tune how the algorithm responds to or takes into account rather the document length in response to when scoring the query responses. So BM25 algorithm adds more flexibility when dealing with documents of varying lengths. It adds a query time weighting based on document length. So BM25, it can be specified as a scoring option along with the document length weighting in all of MarkLogic 12's search APIs. That's the CTS search API, the Optic API, search, JSearch, the REST API. And I'll touch on these options a little bit later when I go through the demo of the vector and hybrid search. The next feature is the shortest path graph algorithm. So the shortest path graph algorithm is an algorithm that's commonly used in routing use cases such as navigation and network analysis. It allows you to find the shortest path between two nodes in a graph or find the paths to all nodes within a certain number of hops from a node. It wasn't really a feature that was envisioned as part of our machine learning or AI roadmap when we first started on it and planned to release it. But as we've seen, any and all techniques are being explored to be able to best identify the most relevant information to feed to large language models for analysis and summarization. And the shortest path algorithm really just adds yet another tool to the platform to allow you to leverage and implement different techniques for RAG, whether that's implemented with using this in combination with a graph RAG process or other innovative RAG approach that you might come up with in the future. The shortest path algorithm is implemented using Sparkle, which is the RDF semantic query language. And it's implemented in Sparkle as what's called a magic property. These are just extensions to the Sparkle language that can be used to add new functionality. And I'm going to go through that in the demonstration in a minute here. But also note that we will be leveraging these magic properties in the future to add additional capabilities to the Sparkle query language, such as the unnest operation as well. So let's take a few minutes to show how to use the shortest path algorithm in Sparkle. Okay. So for this demonstration, I'm going to just work within MarkLogic's query console and show some Sparkle queries that demonstrate how to use the shortest path algorithm. So feel like the canonical demonstration scenario for shortest path is to use the 6 degrees of Kevin Bacon game, and the data is readily accessible, and it's a fun game to play. So with that, for this demonstration, I loaded up a linked movie database export with RDF triples that describe the films and the actors that were in those movies. So we can explore that graph and identify the actors and what movies they acted in with Kevin Bacon, or identify the path to Kevin Bacon from any given actor. So with this, if I just run a simple select here, we can see we have a bunch of RDF triple data, subject, predicates, and objects that show the films that those actors performed in. We can run a query to show what movies Kevin Bacon was in. So we can see these are all, this data set has 38 films. Not sure if that's all of the movies he was in, but it's quite a bit. We can also just use standard Sparkle queries to show what actors were in films with Kevin Bacon, right? So it doesn't require shortest path. We can just run a query to identify what actors also acted in films with Kevin Bacon. So we can see, each of these actors. Aaron Sorkin was in A Few Good Men with Kevin Bacon, etc. It gets more interesting when we want to actually find the shortest path between a given actor and Kevin Bacon. And as I was playing with this data set, I was actually struggling to find actors that were more than 2 degrees of separation, because as it's been proven, that data set is very closely connected. So this query is a Sparkle query that demonstrates the shortest path magic function. So in this query, we specify a starting node called $start. We specify an ending node, the $end. We capture the path in a variable called $path, and we can also specify the length of how many hops between the start and the end. The pattern argument is really important, because this pattern allows you to specify really the pattern of the triples that will be followed to identify the paths. So in this case, in this data, we need to follow the actor name. We need to be able to go from the actor's name, with like Harrison Ford or Kevin Bacon, to an actor subject or IRI. So we need to be able to connect the actor name to an actual actor for the end and the start. We also need to connect the films to the actors for actor 1 and actor 2. And we also want to retrieve back the title of that film. So if we run this query, we specify the start as Harrison Ford and the end as Kevin Bacon. When we run this, this query runs and calculates the shortest path between Harrison Ford and Kevin Bacon. I'm going to run this in a slightly different format so we can see the output a little bit better. So you can see it in JSON. This is the same query. I'm running the query identifying the path between Harrison Ford and Kevin Bacon. Run this, and we can see Harrison Ford is 2 degrees of separation from Kevin Bacon. Harrison Ford was in Air Force One with Gary Oldman, and Gary Oldman was in Criminal Law with Kevin Bacon. If we want to go a little bit further out, we have to pick actor from different generation. We can get more degrees of separation. So we pick Fred Astaire. You can see Fred Astaire actually is still only 3 degrees of separation. Fred Astaire was in The Sky's Limit with Robert Ryan. Robert Ryan was in The Outfit with Joe Baker, and Joe Baker was in Criminal Law, Kevin Bacon. So this is the fundamental gist of the graph shortest path. And this allows us to, as I said, calculate the shortest path between a start and end node and specify basically the types of routes that you want to take between those nodes. One of the also an interesting use case is if you wanted to find the actors that are actually kind of far away from Kevin Bacon, we can change the parameters a little bit and just specify Kevin Bacon as the start and specify the length as greater than or equal to 5. So we're not specifying the end, but we're specifying how far away. And this query will generate a list of all of the actors and the paths that are 5 or more hops away from Kevin Bacon. So if I run this, we can see some other actors, maybe a little less well known, that have been in movies with more than five or more hops of separation between any movie that Kevin Bacon was in. So this is an interesting one for thinking about maybe different RAG approaches with graph RAG, being able to maybe identify the concepts within a certain number of hops from a target concept that you are trying to collect information to feed to the LLM about a particular subject or query. So with that, I'm going to switch back to my slides. Okay, so last but not least, of course, I'm going to talk about the new vector storage and operations that are in MarkLogic 12. MarkLogic 12 Early Access 1 introduces really the first iteration on our vector search roadmap. The capabilities in EA1 allow extraction and storing of vector embeddings in the database and calculation of vector similarity distances, allowing for implementation of techniques such as re-ranking of search results based on vector similarity. We will build on this by adding approximate nearest neighbor indexing capabilities in the final release of MarkLogic 12. These vector operations can be combined with our existing search techniques such as structured metadata queries, full text queries, graph, geospatial, all to be able to implement the most flexible, multi-model, hybrid RAG techniques available. Before I jump into a demo of this, I need to talk a little bit about the Optic API. Optic API is key to understanding how vector operations can be combined with other multi-model queries in MarkLogic. MarkLogic Optic API is really our flagship query language for running multi-model queries in MarkLogic. The Optic API allows you to combine CTS queries, SQL queries, Sparkle queries, geospatial queries, and now vector similarity queries in MarkLogic 12. The Optic API has data accessors, joins, aggregations, and declarative updates that are all composable into a pipeline of operations. Also key to using vector operations in MarkLogic is the template-driven extraction feature. In MarkLogic, you can use a template to specify how you want data to be projected out of documents into different views and graphs. You can project rows or graph data or graphs in the form of triples from JSON or XML documents. You can cast the values that you project out of the documents using a rich language for selecting the data and casting those values into primitive or complex data types, such as geospatial or in MarkLogic 12 vectors. The Optic API is developer friendly. It's meant to be usable from really all of the areas where you would write code to interact with MarkLogic, whether that's server-side JavaScript, an XQuery, a domain-specific language for Optic API, through the REST API, via the Java client, Node client, and also through our Python client. So with that, I'm going to jump in and show you a demo of what it looks like to work with vectors in MarkLogic 12 Early Access 1. Once again, I'm going to be using MarkLogic's Query Console to really look under the covers at what's going on with our vector operations in MarkLogic 12. For this demonstration, I'm using some wiki data that has been collected and has been run through an embedding algorithm to generate embeddings for each of the wiki entries. These are just summaries of wiki entries, so they're small chunks of text. With this, I'm going to show you what the documents look like. In this database, we have a total of about 300,000 documents. Each of the documents looks something like this. We have an ID, we have a title, we have some text, we have the original URL, and then we have a vector embedding that was calculated for the text within this document. So using this data, I'm going to go through a scenario that shows how to combine our traditional MarkLogic multi-model searches with vector re-ranking. In order to get the embedding out of the document and into the vector storage in MarkLogic Server, we need to use a TDE template, as I just described. A TDE template can be represented in XML or in JSON, and it describes how we want to select the data to project into rows or triples. In this case, the vector index is integrated with our row index, and so we need to create a new view called wiki vectors. And within that view, we're going to have a number of columns. We'll have an ID column, a title. We'll even extract the text out into a column. We'll pull the URL. And then the most interesting one, the new thing, the new capability is the vector. So in MarkLogic 12, we have a new scalar type within TDE called vector. And we have a new function called vector, which allows you to construct vectors from a node that you have extracted from a document. So if you have a JSON document with an array of numbers, you just pass that array into the vector function, and that will extract that vector and add it to the vector storage within the MarkLogic storage and indexing engine. You also need to specify how many dimensions that vector is, and note that all of the vectors within a given column need to have the same number of dimensions, otherwise it doesn't work correctly. So with that, let's jump into a scenario. For simplicity, for the demonstration, I've taken a question and I've already run it through an embedding, so I don't have to keep running it. And I've generated a question, and that question is, what species of birds don't fly? I ran it through an embedding model, and I generated a vector for that question, and I stored that in the database as well. Obviously, in a normal query execution, you wouldn't be necessarily storing that in the database, just doing this for the sake of demonstration. If we were to take this simple query of what species of birds don't fly, we could do a naive approach and just break that query into into its words, right? This is English, so I'm just going to split on spaces and generate the words of, that are in that query. I can run a lexical query that finds all of the documents that have those words in them. So let's talk a little bit about what is going on here. So in this query, I'm getting the text, or I'm starting with the text rather, of what species of birds don't fly. I'm going to use a naive approach to split that text into the words, and I'm going to generate a standard CTS query for those words, right? So any of you who are MarkLogic users would be familiar with the CTS query language. I'm going to do an AND query of a collection. This is the Wikidata collection. And I'm going to do a word query on the words that were in that text. And that's just what you would call an OR query, or a shotgun OR query of all of those words. Additionally, I'm going to specify some query options. In this case, I'm going to specify the score method of BM25. So this is the new BM25 scoring algorithm, as I talked about before. If you didn't want to use BM25, you could use this, the default TF-IDF, or you could even use score 0 if you didn't want to take that relevant score into account. And the length weight is the new parameter that allows you to specify the weight of how much the document length impacts that score, right? So a higher weight means that documents that are shorter would be boosted in score. In this case, I'm just going to set it at 0.5. Because most of these documents are approximately the same length, so the length weight is not really impacting this use case that drastically. In this example, I'm generating an optic query. This is an example of an optic query that does a search. I do from search, and I specify the document query and the options that I want. I order by the score. So this is the standard score generated from a CTS query. I only want the top 10 of those, and then I'm going to select a few fields out of the document to return as the results. I'm also just, because I'm interested, I want to know the total number of documents that match my document query that I've specified here. So if I run this, I see there's actually about 200,000 documents match my query, which is not surprising because I think the word, there are some quite common words in there like of and what. But as we know with like TF-IDF, those documents should be lower on the list from a stop word perspective. So let's take a quick look at some of the examples. I see I have right at the top, I have a document that talks about birds. And I even have as a second document here, one that talks about flightless birds. I have some, this is one that talks about hawks. Those are definitely not flightless. Grebes are flightless. I guess elephant birds are flightless. Anyway, so if we go down, we can see down also at the bottom in this top 10, we have some documents that are not really about birds at all, but they do have those keywords or some of those keywords. So right off the bat, we can see, just with a lexical search, it's pretty good. Let's take a look at what we can do with vectors. With the vector operations in MarkLogic 12, we can do a simple scan of the vector storage to identify the documents that have the closest vector similarity to the text embedding that's generated for the question. Now, note, as I mentioned earlier in the introduction slide about the feature, MarkLogic 12 Early Access 1 introduces the vector operations, but we're still working on the actual indexing that would allow this to be fast at scale with millions of documents. But even without an index, we can see that we can use the vectors for simple re-ranking processes, which I'll go into in more detail with the hybrid search. With the vector search, instead of starting from the search, which we did in the previous query, we can start from the view. We can start from the wiki vectors view that we created using the TDE that I showed earlier. From the view, we can create a new column called cosine similarity. That cosine similarity column, we are going to calculate a value that we put into that column using the cosine similarity function. So the cosine similarity function is going to take in two parameters. The first one being the column that contains the embedding that we've extracted from the documents, and the second argument being the query vector, the vector that we have generated that represents the query. So when we run this, we will have a new column that tells us the cosine similarity distance between the source documents in the database and the query vector that we've calculated. We're going to order this by the cosine similarity, and we're going to run the top 10. So we run this. This takes a few seconds. This is just for full disclosure, this is just running on my MacBook in a Docker container with a couple of cores. So even with those 300,000 vectors, it takes a few seconds to run it. We can see, based on the vector similarity, the documents we get back are also interesting. We get some documents about butterflies. We're going to talk about flight, some waterfowl. Here we get one about flightless birds, more about flightless birds, things about the Barcula, which is not this, I guess apparently is not essential for flying. But also, we get we get some documents that are also, not necessarily about flightless birds, but about birds in general, right? So much like the lexical search, we get back a set of documents that sort of vary in actual relevance to the semantic intent of the question. But neither of them are perfect. So let's see if we can make them a little bit better. To do that, we're going to run what I'm calling a hybrid search. Now, keep in mind there's lots of different approaches out there for RAG, as I mentioned, and there's hybrid. RAG means a certain thing to certain people, but hybrid is a very sort of broad word that can mean a combination of different approaches, right? For RAG, in this example here, I'm going to show doing a lexical search using the query mechanism that we already went through, identifying a top candidate list of documents, and then using the vectors to re-rank those to identify a smaller top K number of documents that we could then feed into an LLM. So same setup as before. We have the query. What species birds don't fly. We have the text embedding that we've generated for it. We're going to split that into words, generate a document query for our lexical search. We're going to use BM25. I'm going to specify a few parameters here. I'm going to actually pull back the top 1,000 documents from my lexical search, because I'm really focused on recall for my lexical search, right? And then I'm going to use the vectors to re-rank those documents to identify the top 5 out of those documents. The query vector, I'm gonna construct a vector out of the text embedding that I have generated previously for that question. So now, as I said, I have a few parameters. I have I'm going to do a lexical search for the top 1,000. I'm going to re-rank using a query vector to find the top 5. And then I'm going to use a weighting factor to determine how much the cosine distance score impacts the overall the final score that gets calculated. So if I run this, actually, if I set this to 0, what this does is which should be essentially equivalent to just the lexical search. So if I run this, I see, this should look familiar. The first document I hit is the one about birds. Second one is about flightless birds. The third one's about Harrier. If I increase this though, let's bump this up to 0.5. So now I'm going to use the similarity score to impact the overall final score that gets calculated. So the idea behind this is that I would be able to take the semantic intent that's encoded into the query vector and use that to better identify which of the top 1,000 documents are the actual most relevant for my question. So if I use 0.5, I run that. Now we see actually the top 2 documents are actually, our top 3 documents are about flightless birds, right? So that's working pretty well. So we see flightless birds, grab another one about flightless birds, general one about birds, get this one about butterflies, which is interesting. Not sure why that is, but as we know, none of these algorithms are 100% precise. So this is an example of how we can combine the lexical score with the vector similarity distance to identify the most relevant documents. Let me go through in a little bit more detail what this query looks like. Like the vector query, the standalone vector query, we're going to start with the view, which is the wiki vectors. We're also going to start with the lexical search using from search. And the from search, we're going to limit it to the top K. So this is the top 1,000. And we're going to order those by the score. So now we have the top 1,000 documents. We have a view that has the vectors. Using the Optic API, we can join together the document result set with the vector view, and we can join it on the document ID within those views. We can then generate a column called cosine distance, which we already discussed in the previous example. The cosine distance, which is the distance between the embedding column and the query vector. We can also then create a new column called the hybrid score column. And we can use a helper function that we've created called vector score, which uses that weighting factor and combines the lexical score with the cosine distance score to generate a combination score weighted based on the cosine distance. This is just one algorithm that we've started with. I anticipate we'll be adding more algorithms You can also implement your own, the Optic API is fully functional, and you can add your own calculations to that as well. As before, we'll select out the data that we want to show in the results. And then finally, we're going to order by the hybrid score, and we're going to limit it to the re-ranked top K, which at the top we set that to 5, right? So with that, that wraps up the demonstration for vector operations in MarkLogic 12 Early Access 1. I hope you find that useful. With that, let me switch back to my slides. So in summary, the features in MarkLogic 12 Early Access 1 and what are coming in the generally available MarkLogic 12 release, along with features in other progress products such as Semaphore, DataDirect, and Corticon, all provide a powerful platform for you to be able to build your next generation of AI-powered information retrieval systems. So let's talk about what's coming up in the next few months. So as I've mentioned, this is really a stepping stone in the MarkLogic 12 release roadmap. Over the last year, we've done a number of releases in the MarkLogic 11 line. Most recently, back in June, we did the 11.3 LTS release. In this coming fall, we will be doing a patch release of the MarkLogic 11 LTS, and that'll include support for Red Hat 9, some bug fixes and security vulnerabilities. We'll also be looking to do the next early access release in the MarkLogic 12 timeline, and excited to talk about some additional features that are going to be in MarkLogic 12. MarkLogic 12 general availability is planned for early next year. The general availability of MarkLogic 12 will include a number of new features in addition to what we've talked about today. Building on the capabilities that you have available in Early Access 1, you will also be able to leverage an approximate nearest neighbor vector search index for maximum flexibility on vector operations. We also continue to focus on our scalability and usability themes, as well as observability and additional capabilities that support large-scale analytics. We also continue to target improvements in our platform support roadmap, as I mentioned, including support for Red Hat 9, also Amazon Linux 2023, and we're currently working on support for the AWS Graviton support as well. To get access to the MarkLogic 12 Early Access 1, please sign up for the customer validation program. We'll post a link in the chat. And with that, I'll turn it over to Phil, and we'll wrap things up.
There we go. Cheers, James. Thank you very much for that. Loads and loads of questions from the audience. So really good to see. I think that's a testament to the work that you and the team have put into this. It's there's a lot going on with this release. Just wanted to cover the customer validation program in a little bit more detail, as just sort of, what is it? What do they get? Obviously, you get access to the early release of the MarkLogic 12 with all the features that you've discussed today. But what else does that customer validation program offer?
Yeah, thanks for asking, Philip. I sort of glossed over that pretty quickly. Yeah, the customer validation program is a great opportunity for us to interact with you as our customers. Through the CVP, you'll be able to sign up for early access, but we will, continue to post updates about the early access features within the CVP portal that you get access to when you sign up. In the future, we plan on expanding, the content that we post into CVP. Even even to the extent of giving previews as we go through quarterly planning sessions, giving previews of demos of features and looking for direct feedback from you guys along the way.
Yeah, no, that's great. And yeah, I can't stress enough, it's really worth your time signing up to these things. Like I say, you can try out these new features, but having that connection with the product management team and the engineering team to help kind of shape the product in the way you want it to be shaped going forward into the future can be really valuable. So so please make sure you sign up. There's a link in the chat window below. Right, so let me get through to this list of questions, and we do have a lot, so if we don't get to all of these questions, then we will we'll make sure to cover that in an outreach from ourselves. So the first question we've got is, and I guess is the most important one, are these features part of the MarkLogic package, or will there be additional cost for these new features?
Yeah, so these the three features we talked about today are the BM25 and graph shortest path and vector search. BM25 is just part of the the core MarkLogic search capabilities. The shortest path and vector search are part of the semantic option. So if you have the semantic option already, those features will be included in there.
Yeah, and great. And I guess that comes down to there's another question that just came in at the end, and I'll tack this on to the end. The CVP program, is that a free thing or is that a paid access?
Yeah, that's free. Yeah, it's no extra cost to that at all. Just
Great.
Only cost is for you to interact with me.
Fair enough. All right, well, let's move on to some other questions from the audience then. So first one, can you share any insights on data extraction improvements, especially via ODBC? Currently we write TDEs to extract data via ODBC, and it's a bit of a performance issue compared to APIs. Is there any native support of ODBC without writing TDE in the new version?
Yeah, so it's a good question. It's actually sort of a teaser or a spoiler for what's coming in EA2, but I'll talk a little bit about that. Yeah, so one of the features we're also working on for MarkLogic 12 is, well, we haven't come up with the final name yet, but right now I think we could call it like virtual views in TDE, which basically, the way TDE views work right now, when you create a view, when you ingest the data, it extracts, and it extracts all of the columns into the row or the triple index. We're also working on a capability where you can have a TDE view that doesn't extract the content on ingest time, but builds the views dynamically at query time. So we see this as a very powerful feature for sort of data exploration, being able to more dynamically create views without having to re-index the data. Also being able to run large-scale analytics that maybe those queries are okay to take a couple of minutes to run. They run once a week or something, and you don't want to pay the cost for upfront indexing on with TDE extraction. So there's a number of capabilities related to that we'll be talking about more as we move down the 12 roadmap.
And another great reason to join the CVP program to get access to those as they're discussed as well. So is the shortest path available via CTS, or is it only through the Sparkle and by extension the Optic query?
Yeah, right now it is only available through Sparkle and in the Optic API. In the early access 1, we didn't get it into the Optic API yet, but in EA2 it'll be there. There'll be a specific semantics for using it in, or specific operator rather, for using it in the Optic API. But yeah, it's not currently in the CTS APIs on its own. You need to use it in Optic or Sparkle.
Yeah, and there are some great resources on the Optic via the website, so I'd recommend if you haven't checked those out, or if you're new to Optic, then please do check that out. And if you've got any questions, feel free to reach out, and we'll see if we can get you connected to the right person. Can you also do something like weighted steps for like calculating shortest navigation route by accumulating distance in kilometers or time?
Yeah, so it's a good question. The current capability is not a weighted shortest path, but yeah, it's a logical next step in that feature. But yeah, currently it's not weighted.
And is it possible to derive the vector from the document as a part of the TDE process, or does it have to be pre-calculated as in the demo?
Right. So yeah, that's a really good question, and yeah, it helps to understand set the context for what I'm showing here, right? I'm really showing at the boundaries of MarkLogic server, right? The core capability is the vector query and ultimately indexing and query capability, and that's built into the server. The actual call out to a language model for calculating embeddings is outside of the scope of the server as we currently have it planned, right? So we're working on building those types of features into the tooling that go around the server. You would be able to use frameworks such as LangChain or Llama Index to make the call out to the language model and calculate the embeddings and then write those documents to MarkLogic. So yeah, currently that calculation is outside the context of outside the boundaries of MarkLogic server.
Yeah. And in this search, the semantic search, can you pass filters?
Yeah, so hopefully that, I mean, I think, looking at the timestamp, it looks like that question was asked a little bit early. Hopefully, maybe from the hybrid search demo that was answered for you, right? So, yeah, you can combine lexical searches with the vector similarity queries, and it really highlights the power of being able to compose these features together, right? So, the hybrid search approach that I showed there allows you to leverage your already indexed corpus using the powerful query language or query capabilities in CTS, for lexical search or exact match or range queries, etc., to narrow down the documents that you want to work with, and then use the vectors, say, to re-rank those. Or we're also working on some methodologies for progressively enhancing those documents. So maybe when you run that query, you don't have the vectors, and so you want to take the result set and then actually call out and vectorize those documents and then do the re-ranking. So you can sort of progressively add vectors to your data based on what people are interacting with.
Yeah, so rather than having to vectorize the whole data set, you're doing it based on kind of the user's query and the use of that data, and saying, actually, this would be good as a vector candidate to vectorize this.
Yeah, exactly, because I think, as everybody understands, it can be costly to go back and vectorize all of your content up front.
And is it possible to show the query one.json, and how would you kind of map that search string to the vector?
Oh, well, to switch back to my screen, I think I can just describe it.
Yeah, describe it, and then if we need to, we'll catch up with the questionnaire afterwards.
Yeah, there's a lot more, but fundamentally, the query1.json is just a JSON document that has a JSON array of numbers in it. It's a vector vector embedding.
Yeah. And in the example, you're using fragments. Is this automatic with the embeddings to break up the fragments, or is it something you have to do on ingestion?
Yeah, so that might be triggered off the use of the fragment ID mentioned in the optic query. So in the optic query language, as some of you have been using MarkLogic for a while would know, right? In MarkLogic, a document is actually a fragment, right? So like you have the sort of primary fragment which represents the document. You have property fragments, and then you can take documents and break them up into subfragments. We're not changing anything about the way fragmentation works in MarkLogic. The mention of fragment IDs in optic is really about being able to join the rows that have the vectors with the documents based on really the document ID. We call it the fragment ID in optic, but it's the document fragment. If that's sorry if that's a little confusing, but we're not fragmenting anything in using the MarkLogic fragmentation feature.
Yeah.
Any sort of chunking or dividing the documents up would be done outside of the server at this point. Using one of the frameworks that we discussed, or some of the tooling that we're actually in the process of developing right now.
Yeah. And I see complex queries are executed from the query console with JavaScript, and that's good. It would be helpful if you could share insights as how we can use such queries via application.
Yeah, so I guess that connects back to what I was talking about before with, say, Llama Index or LangChain. Yeah, there's some examples out there. We haven't released new Llama Index examples using the MarkLogic 12 early access features yet, but we're working on that. And there is an example in our Python driver that uses LangChain just with MarkLogic 11 query capabilities as a retriever. So welcome to take a look at that, and yeah, keep your eyes out for coming examples of using the 12 EA features in those frameworks.
Yeah, and I think we'd be really interested to see how you guys are using that as well. So if you come up with examples that you're willing to share with the community, we'd definitely be interested to see what you're doing with the technology and other tools in the ecosystem like LangChain and Langsmith. So we're coming up to the top of the hour now. There are still quite a few more questions. I don't think we're going to get through to all of them today. I guess I think this is a really good step for MarkLogic. I think it's fairly unique in some respects in terms of that multimodal search combined with vectors, combined with the ability to store and ingest data as we do, and it's a really interesting addition to the product. As you mentioned, there's other vector features and features coming down the line to increase the flexibility of the tool, to increase the functionality of it in the platform as well. So it's really interesting to see. We'll reach out to those people who have asked questions today. One, if we didn't get to you, but two, if you wanted more follow-up, we'll make sure to connect you to the right people. James, thank you very much for your time today. Thank you for putting those demos together. I'm sure they'll be referenced by our team with our customers as well. Thank you very much for attending today. Yeah, we look forward to seeing you in our next session. Thank you very much.
Thanks, everyone.